Hey, Spencer.
Hey, lad. Is this going to be a meeting or with other people online or just you and me?
It's going to be a meeting.
Okay. All right. So tell me when, are we ready to start right now?
If you're ready, your camera's off.
Oh, sorry about that. Let me fix that.
But we can,
start video. There it is. Okay. All right. How are you doing?
tired.
Yeah. All right. So,
All right. I've been waiting. I've been holding people in the waiting room so we can just admit all whenever we're good to go.
we're good to go.
All right. All right. Well, looks like we have a couple people, but so today we have kind of a bit of an different webinar. We have, or Spencer has a new product that he is currently launching. So, and we're kind of, I am not entirely sure what it is. So we're all kind of here to learn about it. So whenever you're ready, Spencer, you can.
Sure. So thanks for having me, lad. So what I want to talk to you today about is about the microbiome and what it is, what it does for you, how it fails, and then what we can do to fix it. So there are 7 secrets that I will share with you about the healthy microbiome. But first, I have to explain what the microbiome is. Not everybody knows. So the microbiome is a community of bacteria, viruses, and yeast living in your gut, and they're responsible for the proper development and regulation of your immune system in your brain. They suppress and kill bad bacteria and fungi. They make vitamins, they break down toxins, and it's responsible for managing the homeostasis of your body, including neurotransmitters, hormone levels, antibody levels, body fat, blood sugar, insulin sensitivity, energy production, sleep cycles. It runs the whole show. It's the main regulatory system for your entire body. So in other words, if you want to have a good health, you've got to have a healthy microbiome. If I ask most people to draw a tree, they draw a trunk and branches and leaves, but that's only the top half of the tree. The bottom half of the tree, which is just as big as the top half, is the roots and the bacteria living on the roots and doing all the metabolic action for absorbing things. So think of the microbiome as the roots of the tree in your body. It's just as important as almost everything else in your body is, but it's kind of hidden behind the scenes. If you were to take all of the endocrine glands, the gonads, the thyroid, the thymus all together, and put them all on one side of a scale, and then put the endocrine system of your gut on the other, it's about the same size. And if you take the size of the brain, the weight of the brain at around 2.5 pounds and the gut at 6 pounds, then it's bigger than the brain. So it has an enormous effect on your life. And it's not something we normally notice nor take care of. So the first question is, where do we get this thing? And based on archaeological studies, we've been around for about 800,000 years, right? And in that time, our diet was mostly tubers, insects, fruit, seafood, wild game, with nuts, seaweed, and honey now again, if we were lucky. And all of these foods contain specific sugars called oligosaccharides. And since you might not know what oligosaccharide is, I'll explain it. There's 3 classes of sugars that we eat. There's the simple sugars like fruit and honey, and they're small and you can digest them easily. And then there's complex sugars like starch. You find them in grains and beans, and we can digest those. But then there's these medium-sized sugars that are larger than the small ones and smaller than the big ones, and they're called oligosaccharides, and we can't digest them. And what happened is, as we're eating tubers full of these oligosaccharides, as we're eating the tubers, as primitive humans, we're also eating the soil, which is full of bacteria. The bacteria can definitely eat those oligosaccharides. So what happens is the bacteria get in the gut, And they're eating these sugars we can't eat, so it's no loss for us. And they find themselves in a place that's warm, moist, dark, no oxygen, and lots of food. So they set up shop and they colonized us. And over time, they became symbiotic with us because the healthier we are and the longer we live, the better it is for them because they've got this great place to live. So the first trick they learned when they're becoming symbiotic is how to kill the bad bacteria. If a bacteria came in that wasn't good for us, they killed it because they want us to be healthy. But it didn't stop there. The bacteria in our gut, which is now our microbiome, learned how to make us stronger, smarter, fight infections better, heal faster, age slower. In other words, the microbiome was and still is today the most powerful upgrade human beings are ever going to have. Now, the microbiomes originally were passed on person to person. You shook hands with somebody, you ate food, you got microbiome, but it also is passing on from mother to child. And during pregnancy, the mother's microbiome actually shifts to that of a baby form. It becomes much more full of bifidobacteria. And then during childbirth, the baby gets some of that bacteria in the birthing process. Now, once the baby's on the outside, breast milk from the mother is going to contain about 200 different types of oligosaccharides right in the milk. As a matter of fact, if you were to break the milk down into its constituents, you'd find there's more oligosaccharides than protein, which is kind of interesting, right? You think the breast milk would put a priority on growing the baby, but it actually puts a priority on growing the microbiome. So what this tells you is, from Mother Nature's perspective, not only do you want a lot of microbiomes, but you want a lot of different microbiomes. Not only do you want a lot of oligosaccharides in terms of quantity, you want a lot of different types of them also, especially when a baby's young, because otherwise the wrong things are going to colonize it. So by about 2.5 years of age, the baby's microbiome is pretty much that of an adult. It's now shifting from the lactobacillus, which is found in the birthing canal, and the bifidus, which was found in the microbiome of the mother, and it's shifting into Bacteroides and Firmicutes. And then the reason this happens is because the baby's no longer having breast milk, and it's no longer feeding those two forms, it's feeding other things. And the takeaway from this is you can control the makeup of the microbiome by controlling what you feed it. Now, there's 4 different initiations that happen for the microbiome that most people aren't aware of. Heck, I wasn't aware of them until I started studying this. First thing that happens is when you're inside the womb, the mother's microbiome is actually guiding the development of the child's brain before it's even born. It's guiding its architecture of where the complexity of the brain is going to be. So it's actually making us human. It's making us smarter and building our personality before we're even born. The next thing that happens is once we're born, our colostrum, which is full of IgA, which is a immunoglobulin, comes out in breast milk, and it teaches the baby's immune system that the microbiome is actually self. Don't attack it, it's here to help. And it also increases the complexity of certain parts of the brain. When we're born, our brains aren't completed yet. There's still a lot of myelination to be finished and a lot more growth to be done. So the microbiome of the baby's gut now is going to be generating complexity and growth in the frontal cortexes, where you get complex cognitive behavior, personality expression, decision-making, social behavior, things like that. And then the hippocampus farther back, which gives you the memory. And then finally, the microbiome is responsible for teaching you what other is, right? It told you what self is. It's don't fight this. And then it tells you what other is, but go fight that. And it's important for the immune system to learn what self and other is, because that's without that, the immune system can't function properly. People who have autoimmune problems, these are people that don't know what self is. They attack themselves. And people who have weak immune systems, these are people that don't know what other is. They don't attack others. It's the microbiome that's responsible for this. Now, we might not get off to a good start if we end up with, say, cesarean or mid-forceps or sunny side up delivery or premature birth. That can cause some problems to the microbiome. And then if we're not breastfed, because there's 200 different, like I said, 200 different oligosaccharides in breast milk, and it changes based on the needs of the baby. If the baby's born prematurely, breast milk changes for the baby in that particular way. It also contains some 600 different probiotic strains, which are being pulled up from the mother's own microbiome into the lymphatics, into the breast milk. So breast milk's always going to be better, even as far as we've come with formula. Formula is going to end up giving the baby the microbiome of an elderly person. It's going to be mostly Bacteroides. So there's a lot of ways which, if the birth sequence goes wrong or we're not breastfed, we don't get a good microbiome. The other thing is, none of us are feeding it properly because we're not eating primitive diets. And we're taking things in like glyphosates, which wreck the microbiome, artificial sugars, which confuse the microbiome, emulsifiers, which break down the gut wall, statins, anti-inflammatory drugs, oral hormones, SSRIs. All these things are like microbiome mass casualty events, totally wrecks the biome. You can recover from it. It's a lot of work. Then you get stuff like antibiotics and severe intestinal infections. So a salmonella infection can knock out 15% of the microbiome, but heck, Cipro can knock out 50% of the microbiome. So actually antibiotics can be worse than intestinal infections. And those are more like microbiome extinction level events. Those take a lot of work to recover from. Again, it's doable. But what happens is each generation has a weaker and weaker microbiome to pass on to the next. And we're now at the point 3 generations into antibiotics and the chemicals we put into food that we're seeing a collapse of keystone species, meaning those species without which the microbiome can't survive. And we're now starting to see the collapse of the microbiome in people. It's important that we fix this not only ourselves, but we've got to fix this for women of childbearing age, because one more generation like this, and there's just going to be no microbiome left for the mothers to pass on to their kids. And then we're going to see yet another skyrocketing of autism. We went from like we thought from 1 out of 60 to 1 out of whatever 30 or something it is now is a lot. It's going to go down like to 1 out of 4 or 5, and the microbiomes collapse wholesale. So it's important to repair the microbiomes of the mothers so that they can pass these on to not only their children, but the children's children, and so forth and so on. So, the first question is, how do you know if you've got a bad microbiome? Well, okay, you can do a $500 stool test, and those are great to do. But let me teach you 4 ways you can check real easily. The first question is, does your stool smell bad? A healthy microbiome has almost no smell. The second is, how much toilet paper do you need? A healthy microbiome doesn't create soiling, meaning you wipe once when you go to the bathroom and there's nothing there, the toilet paper is clean. The more toilet paper you need, the sicker the microbiome. The third is transit time. How long does it take to go from when you eat food to when it gets defecated out? It should take 18 hours, and you can test this with 2 tablespoons of blueberry extract, organic blueberry powder, and just see how long it takes for your, the stool to turn purple or blue. Now, a lot of people will say, well, God, I'm not constipated. I go to the bathroom every day. I'm like, okay, yes, but was that food that you ate yesterday, or was that food from a week ago? Because you can go to the bathroom every day, but it's from 7 days ago. And then the last thing is checking your stool pH. And you can do that with pH paper. Just make sure you get the pH paper that goes from 6 to 8. The stuff that goes from 4 to 10 is too wide of a range. You won't be able to see anything. And you want your stool pH to be 6.6. As long as a person doesn't have really dry, kind of pebbly poop, like what rodents make when they're, as long as they have somewhat normal stool, it'll be moist enough that if you put pH paper on it, you're going to get a pH reading, and you want 6.6. Just because you have 6.6 doesn't mean you've got a good pH, doesn't mean your stool's good. But if it's above 7.0 or below 6.2, it definitely means it's out of whack. Okay. So how do you recover a good microbiome? Well, the first thought people would have is, well, I'll just take probiotics, right? I'll have some yogurt and some cultured food, my grandma's kimchi. Okay. So let's talk about that. The first probiotics we learned how to make were, they contained lactobacillus and bifidus, which is mostly found in the baby gut. And they turned crushed vegetables and milk respectively into sauerkraut and yogurt. The challenge is that these probiotics, the bifidus and lactobacillus, like I said, these are found in the infant gut. They're not meant for an adult gut. Lactobacillus is mostly received through the vaginal canal of the mother, and it's for your skin mostly, not for your gut. So together, lactobacillus and bifidus really only account for about 0.01% of the microbiome, about 1/10,000th of it. So if you see a lot of lactobacillus in the human gut, it's a problem. The reason why this is what's available is because these are the easiest ones to grow in bulk because they are somewhat resistant to oxygen. But in the gut, there's no oxygen. So the bacteria that grow in the gut are typically the low oxygen bacteria. And these are very difficult technically to grow in commercial scale. We are at the point where we're starting to see the creation of, industrial scale human gut simulators that will grow the bacteria you actually have to have. But we're still a couple of years away from that. So yeah, you can take probiotics, but they're not going to be the ones you need. And because they are they have evolved to grow in a lab versus grow in the gut, they're probably not going to colonize human tissue. They're just going to be good for, you take them and they're good while you've got them in you, and that's about it. It also gets a little tricky because some probiotics increase histamine, some lower it. Some increase GABA, some increase glutamate, some increase methylation, some lower methylation. So if you happen to have a methylation defect or glutamate sensitivity or a histamine issue, and you get the wrong probiotic, you could actually make yourself worse. I would say that there's a time for taking probiotics, and I'll tell you the protocol for that. But you don't want to micromanage a microbiome. It's really not even possible. What you want to do is you want to feed the microbiome and then let it manage itself. So then the question is, well, then where are you going to get the bacteria if you don't have them? If they've been knocked out by antibiotics or something, what do you do? Okay, there's 3 reserves for good bacteria. The first is the dormant bacteria hibernating in the gut mucosa, right? Because if you just don't feed your gut long enough, your mucosa if you don't feed the bacteria in your gut, your microbiome, one of the strategies the microbiome has is just to go to sleep and wait for you to eat more oligosaccharides. So then if you do give it the oligosaccharides, it can then repopulate. So the first reserve you have is just your own gut. They're just sleeping or in very, very low numbers. The second is in your appendix. Now, I know we're often taught that the appendix is a vestigial organ with no real use. Actually, it's the backup copy of your microbiome. So when someone gets salmonella and vicious diarrhea, they can repopulate themselves from the appendix. The problem is if somebody takes something like Cipro, they can knock out the good bacteria even in their appendix. So they could lose that one. The third reserve is every person you meet and everywhere you go. Microbiome is on everybody's hands. It's in the air. It's everywhere you go. It's every bit of food you eat. So, you're always being exposed to it. Now, since there's always some oligosaccharides in the diet, even if only in tiny amounts, it's pretty unusual for all the species, for the species of the good bacteria to be completely wiped out unless you've taken antibiotics and heavy doses. Usually they're alive just in very small amounts. And as long as you take the oligosaccharides to feed them, they'll repopulate. Now, if you consider that a bacteria with a doubling time of 20 minutes can go from 1 bacteria to 34 billion in 12 hours, you realize it doesn't take long to regrow your gut microbiome. It just means you have to feed it. Okay, so we've gone through the basics of the microbiome. And let's get on to the 7 secrets I promised you. So the first secret is oligosaccharides. We have to eat the sugars that we've been eating for the last 190,000 years that our microbiome needs to survive. Now, can you get enough of them with diet? Maybe. First off, you'd have to have an excellent digestion to break the oligosaccharides free of what they're stored in, all right? And then the second is you have to eat a lot of foods you probably don't want to eat, like tubers, like Jerusalem artichoke, roots like chicory, insects and mushrooms and seaweed would have to be on the menu. I think the best option is to go with a supplement. So I've got one over here that we make, and it's got all of the oligosaccharides that I could find in the ratio that I believe you would be getting if you had the most successful hunter-gatherer diet of all time. So what you do is you take a 1/4 teaspoon, you put it on your food with each meal, and you are simulating being the world's most amazing hunter-gatherer, eating primitive food. And what it contains are some things you'll probably have heard of. It's got a galacto-oligosaccharides. That's what you find in beans, or if you're a primitive eater, tubers. It's got fructo-oligosaccharides, xylo-oligosaccharides, and pectin-oligosaccharides that you find in fruits and vegetables. But you'd have to go and be eating, fruits and vegetables from multiple continents to get this many. It's got the connective tissue oligosaccharides you find in wild game. You don't find it so much in factory farmed meat because they're bred to have very low amounts of connective tissue to make the meat tender. It's got chitin oligosaccharides that you find in mushrooms and insects. It's got fucoidin oligosaccharides you would find in seaweed, and isomalto oligosaccharides you find in honey, miso, and kimchi. It's very concentrated. It's very absorbable. And to put it in context, one serving has 200 times more galacto-oligosaccharides than beans and 300 times more fructo-oligosaccharides than Brussels sprouts, which are both very high levels for those kind of foods. Now, one question is, geez, why did you have to put so many oligosaccharides in this? Well, there's three reasons. First, oligosaccharides act as decoy molecules that prevents bad bacteria and fungi from attaching to the gut wall. So the wider the range of oligosaccharides you have, the wider a range of bacteria and fungi, the bad ones that you can keep from attaching. The second is different bacteria have different food requirements. So the more oligosaccharides you eat of different types, the more different types of bacteria you can grow in your microbiome. And that means the greater microbial diversity, genetic diversity. And I'll tell you in a minute why you want a really huge genetic diversity in your microbiome. And then third, oligosaccharides are not interchangeable. And I'll give you an example of this. I had a friend who was in her 20s. She was 2 years into a very bad health crisis. And I did a questionnaire on her, and basically every organ system you can imagine was out of whack. The gut was out of whack, but it was definitely not number one. It was like number 4 or 5 or something. And, we went through the number 1, 2, 3, 4 things. We checked her at a cardiologist. We checked her endocrine system. We went through all these things, and although they were out of whack, the systems themselves weren't damaged. Finally, I said, all right, well, let's try your gut. And I made her this product. I made all 8 oligosaccharides for her. And in 3 days, she had regained half of her health. She had up until that point, she might be found laying on the ground for half an hour unable to move. Her chronic fatigue was that bad. 3 days into it, she's 50% better. Everybody's thrilled. And then I run out of one of the 8 oligosaccharides. So I was like, all right, well, you're getting the rest of them, and it shouldn't be a problem. And she, within 3 days, she's, worse and worse and worse. And on the third day, she's back to where she started, collapsing again. I said, okay, well, maybe you needed that one. So I got that oligosaccharide back for her again. I found it from another source. 3 days later, she's back and recovered again. Now, there's 2 takeaways for this, right? Takeaway number 1, these oligosaccharides are not interchangeable, right? It's not like you can just say, well, I'm going to take this one, but not that one, and that should do the job. The second, you never know which one that person's going to need. The second thing is, if you give the body the oligosaccharides it needs, it can repair itself pretty darn quick. She was able to recover mostly from a degenerating condition that she had been going through for 2 years in a couple of days. And that's, again, because the bacteria grows so fast. The second secret is fiber. Now, so we've been here for 200,000 years, right? 100,000, or in our modern form. 190,000 years, we've been hunter-gatherers. In the last 10,000 years, we were farmers. And of that last 10,000 years, we were here for 200,000 years as hunter-gatherers. Then we were farmers for 10,000 years. And then like the last 100 years, it's been modern man. Now, hunter-gatherers got something like 100 grams of fiber in their diet. Farmers, about 35, and modern man eats about 15. Now, to eat like a hunter-gatherer, to get 100 grams of fiber, you're going to be eating tubers all day long, and that's just a lot of work. But 15 grams of fiber for modern man is not enough. So I'm aiming at 35 grams, which is like the last, 1,000 generations or however many for 10,000 years of farmers that we've been having since we started cultivating beans and grains. Beans were actually the first things we ever cultivated. If you consider that for every 10 grams of fiber you eat, you decrease your total risk of mortality by 10%, that means if you get from 15 to 35 grams of fiber, you've decreased all risk of mortality by 20%, which is huge. So how do you do that? You might say, okay, I'm gonna eat a lot of salad. Okay, but a cup of carrots is like 3 grams of fiber. It's not enough. A cup of beans has 17 grams. So it's beans. If you want to get fiber, you're gonna have to eat beans. And you can get to 35 grams pretty comfortably per day with eating beans. The only thing is you might give you a little bit of gas. So 2 suggestions for that. One is try Adzuki beans because they don't make that much gas. And secondly, soak and rinse them for 24 hours. And if you do those 2 things, the beans shouldn't cause you any trouble. Now, some people would say, well, why can't I just take a fiber supplement? Okay, let me tell you the side effects with that. Insoluble fiber can damage the gut. And soluble fiber can create methane gas, which aside from being socially challenging as flatulence, also paralyzes the intestine, so it slows down transit time, which means it takes more time to get from point A to point B. So my suggestion is don't do fiber. And if you feel the need for mucilage, that the gel-like fiber to kind of repair the damaged gut, go with animal-based mucilage like Jello and gelatin and beef bone broth rather than plant-based, because the plant-based ones, they just ferment too much for most people. Because the main thing is if you take a lot of fiber, you would think it's going to help with constipation. It does in some ways. It'll make you more regular, but it'll make you regular but very slow. It'll slow down transit time, which takes us to transit time. So the food in our body, it should take about 4 hours in the stomach, depending on whether it's fruit to meat, 6 hours in the small intestine, and then 10 hours in the large intestine. So it should be through you in about 18 hours. If your transit time is faster than 16 hours, you're not able to absorb the food properly, and that's malnourishing. But for most people, the issue is they're going to have transit times of 2, 3, 4, 5 days because we spend so much time sitting. And they'll tell you they're not constipated because they go to the bathroom every day, but what they're releasing is something that they ate 7 days ago. Even though it happens every day, it's 7 days backlog. So there are things people can do. They could take Cascara Sagrada. There are herbs that will stimulate peristalsis, but they're addictive. And then it wears off, and then you have to take more and more to get the same effect. And then eventually when you stop, there's no transit time at all. So let's talk about how you accelerate transit time. One way is exercise. So consider the Hadza of Tanzania. They're the most well-studied group of primitive people, hunter-gatherers. They eat about 100 grams of fiber a day, but they also exercise 135 minutes a day. So that comes to about 1.35 minutes of exercise for every gram of fiber. So if you eat the standard 15 grams of fiber, that means you should be doing at least a 20-minute hike or a 30-minute walk once a day. If you're going to go to the 35 grams, which is what I would suggest, you're looking at about an hour walk once a day. Now, intestinal transit and peristalsis, it is a very muscular activity. There's all these muscles that are in the gut, and they all have to squeeze quite hard to move the food through. So this is one of the reasons why exercise speeds up transit time, specifically cardio. If you don't have good cardio, then you're probably going to have a slow transit time, because it's the same kind of endurance muscle action that you build up by doing calisthenics and running and jogging that is required for the same kind of strength of peristalsis. Also, there are probiotics you can use to increase peristaltic speed if you need to, be animalis and be lactis. But I think exercise is a more effective way to do it. Otherwise, you're going to be taking probiotics forever. I don't think you can replace exercise with probiotics. You can take butyric acid, and that will speed up your gut transit time, which is a short-chain fatty acid made by Healthy Gut. But the goal long-term is that your gut's doing that for you. So again, feed the gut, it'll make the butyrate for you. But in the beginning, a little butyrate doesn't hurt. You also have to keep calm. The rest and digest parasympathetic system speeds transit time, but the fight or flight sympathetic system slows it down. So if you are upset all the time, or especially if you eat when you're upset, you can expect it to sit around in your gut for a while. Now, another thing to the key to this is don't eat late in the evening. There's a special kind of peristalsis called the giant migrating contraction. That is how the gut cleans itself up with the leftover debris. And it does this a couple of times a day. And the small intestines won't do this if there's any food in them. So if you were to eat at 8 o'clock at night, that means there's food in your stomach, if it's a decent meal, till midnight. That means it's then in your small intestines till 6 in the morning. Now, depending on when you wake up, let's say you wake up at 6 in the morning, that meant you never got the giant migrating contraction of the small intestine. It never cleaned itself that day. And if you do that every day, your gut's never cleaning itself. So depending on what time you wake up, try to eat by 5. That will at least give you 3 hours in the middle of the night where your gut can do its cleansing process. Another thing about transit time is methane production. Methane is produced by an unhealthy gut when there's not enough sulfate in your diet, and it goes and you start turning hydrogen into methane. And it's not just inconvenient and embarrassing in terms of flatulence. Methane is actually a paralytic agent, and it paralyzes the gut muscles so that you can have a very long transit. If you have gas, you may very well have a very slow transit time. And an easy trick for this is methane is produced by methanogens, which are extremophile bacteria that only can grow under very harsh conditions. And if you have a little bit of sulfate in your diet, which I take as Epsom salts, USP grade Epsom salts, I do 1/8 of a teaspoon in water 4 or 5 times a day, that will cause the hydrogen to turn into acetate, which you need via the acetate producing bacteria. The only way that the methane producing bacteria have a chance is if you have very little sulfate in your body. Unfortunately, most diets don't contain sulfate, so that's not that uncommon. Okay, another secret is don't eat more than you can digest, okay? And it's important that the only thing that enters your large intestine is fiber and oligosaccharides. I'll say it again because it's so important. The only thing that should enter your large intestine is fiber and oligosaccharides. If you eat more than you can digest, that's either you ate too much food or you couldn't eat the food that you ate because the digestion was off. Then it spills over, the undigested foods spill over into the large intestine and create all sorts of problems. So if protein or fat gets into the large intestine, it stimulates the growth of a putrefying form of Clostridia, the same ones that digest the protein and fat in corpses and make some horrific end products, things with names like putrescine and cadaverine. And you can imagine how bad those things smell and what kind of mess they cause in the body. And if carbohydrates get into the large intestine, they ferment and create gas and alcohol and formaldehydes and feed candida. So you don't want undigested food getting into your large intestine. This is why transit time is so important. So if you do overeat, you went to a family barbecue and had more meat than you can digest, and then had a great big cake at a birthday party with all these carbohydrates, at least they're not spending a week sitting in there, right? You flush them through if you feast. Which leads us to our fifth secret. So that's digestion. Hang on one second. So we don't want to have the dysbiosis and putrefaction in the large intestine. And that means we can't have undigested food there. Well, what happens if you're not eating too much, but you're still not, if you have a weak pancreas and you can't digest properly, then even if you eat a small amount, it's gonna spill over into the large intestine and create these problems. So a couple of things. One, make sure you chew your food well. And if you don't have a good bite alignment, go see a dentist. 2, you got to make sure your bile is flowing because that's part of your digestive process. And if it's not, you could consider our Glytamins product. And then 3, if you are still having some pancreatic issues, go and order some pancreatic digestive enzymes and take them with your food to make sure that you're not overflowing these things into the large intestine. Now, if your stool or your body or your breath or any smells bad, that's probably protein putrefying in the large intestine. And if you have gas, that's probably carbohydrates fermenting in the large intestine. And if you have gas that smells bad, then you've probably got both carbohydrates and protein making a mess down there. So again, don't eat more than you can digest and make sure you can digest well. There's another secret. It's retrograde starches and beta glucans. These are 2 prebiotics that are not in the formula because you need them in large amounts. It wouldn't have enough room for the other things I want to put in there, and they're cheap and easy to make yourself. So a retrograde starch is what happens when you take like cooked beans or grains or potatoes and you put them in the fridge for 4 hours and they turn into a crystalline structure. They turn into a prebiotic. It also lowers the glycemic index, so they're great for people who want to eat these things but have blood sugar control issues. And that acts as a prebiotic for the bacteria. And then if you choose oats as the grain you're going to make your resistant starch out of, now you've got the beta glucans, which is yet another prebiotic. So here's a secret for you: cook up some oats, put them in the fridge for 4 hours and eat a little bit. And that turns it to a time-release prebiotic. All right, seventh secret, and then we can get on some questions, is a good attitude. So your microbiome affects your mood, but your mood also affects your microbiome. The microbiome produces, consumes, and regulates the neurochemicals that create our emotions. And our emotions stimulate the growth of various bacteria. We didn't invent serotonin. The bacteria invented serotonin. All these neurotransmitters, they're the ones that started it, 3.5 billion years ago. We're using for our own brains the chemicals that they invented. So they are fully capable of making and regulating and using neurotransmitters because they're the ones that created them in the first place. So the emotions that for us of fear, anger, and stress, that would be the chemicals adrenaline, noradrenaline, cortisol. They stimulate the growth of pathological bacteria, and they increase the virulence of bacteria that would otherwise be harmless. On the other hand, oxytocin, which is the neurotransmitter released with feelings of love and compassion, supports the growth of good bacteria, and good bacteria make oxytocin. So it's either a vicious or virtuous cycle. It's up to us which one. If we can maintain a good attitude, we will grow the bacteria that will help us maintain a good attitude. If we let ourselves delve into a bad attitude, we're going to grow the bacteria that makes us more likely in the future to have a bad attitude. So attitude is important. So, the microbiome is an ancient intelligence with a lineage going back 3.5 billion years. It's a very powerful ally. It's the most powerful upgrade you'll ever do. And it's been guiding and protecting us since before we were even born. And now you know the secrets to take care of it. It's pretty straightforward. Feed it oligosaccharides, take a walk every day, add some beans to your diet. Don't overeat, and stay positive. And that's my initial talk on the microbiome. Do you guys have any questions? Can't hear you.
I said that was a lot of really good information.
Thanks, Vlad.
My computer decided to die, even though it's plugged in. So I'm on my cell phone.
Oh,
so okay. So excuse the cumbersome, being a little cumbersome here. But we can go to questions if anybody has questions. You can just drop it in the chat. So, but this is
okay.
Yeah.
And if not, I will go on to some of these other things we could talk about. We could get
sure. Well,
you
can keep going, and then people can start dropping questions in the chat.
All right. So one of the things that happens with spillover when you have stuff growing in your large intestine you don't want is it teaches the bacteria to eat us. Right? We're not made of fiber. We're not made of oligosaccharides. So it's fine that they learn how to eat that because we're not made out of it. But we are made out of protein, fat, and carbohydrates. So if you have protein spilling over into the large intestine, you're going to cultivate bacteria that eat protein. Well, our internal organs and muscles are made out of protein, and a bad microbiome will leak that bacteria into the body, and then it's going to start eating the protein inside of you. If you have carbohydrates spill over into your large intestine and you cultivate bacteria that eats carbohydrates, and that gets into your bloodstream, well, your joints and your cartilage are made of carbohydrates. You can start eating your joints. And if you have fat spilling over, you're teaching your microbiome to eat fat. Well, the brain's made out of fat. I don't want to have my brain being eaten. So again, spillover is a huge thing. So another question is, aside from the 4 tests I gave you, the pH, so forth, how else would you recognize a sick microbiome? Well, the main thing is it doesn't usually present as digestive. As a matter of fact, the microbiome is not mostly a digestive organ. It's actually mostly a regulatory organ. It also does a lot of work with digestion, but it does a lot of work with other things too. So what you see with when someone's got a sick microbiome, typically you're going to see fatigue, and you're going to see brain fog, and you're going to see emotional instability or a lot of moodiness. So that's the key. When you see someone who's tired a lot, who's cranky, who can't think well, and doesn't react well to emotional stress, think microbiome. I mean, so here's something interesting. They gave probiotics to women and then showed them pictures of faces of upset people and then measured their brain. And what they found was that if they took probiotics, therefore temporarily had a good microbiome, then the stimulus of the upset face did not bother them as much. So what that's saying is when you see someone who's a people pleaser, who can't say no, who doesn't have good boundaries, what they're really telling you is their gut's out of whack. Because you fix their gut, then all of a sudden, yes, they're very sorry that the person they see is upset, but they're not letting it throw them for a loop, you know?
Yeah.
So let me see. Let's talk a little bit about parasites. I think that's an interesting conversation. Parasites are a very ancient adversary. So the mammalian immune system is about 200 million years old, but parasites have been around for over 500 million years, infecting us and our pre-mammalian ancestors. And in that immense time frame, they have learned some really sophisticated strategies to evade, suppress, and attack our immune system. So one of the things parasites do is they can hide inside of ourselves or inside the cell tissue. They can go inside the cells. They can also manipulate cytokine and interleukin signals to make our immune system more docile. They can attack our immune system directly, but I think their greatest trick is that they can hide. They can cloak themselves so the immune system can't see them. Now consider T. brucei. It's the parasite that causes sleeping sickness in Africa. It's got over 2,000 genes that code for the major protein that's expressed on its surface. It, like all parasites, is a master of disguise. It's got 2,000 different outfits it can wear. So what happens is it'll wear one outfit, it'll have one coating, and then the immune system slowly figures out that that's an issue. And then it says, all right, no worries. And it switches to another one. And then the immune system can't see it again. And so what you get with people is, you know, they can get diseases where either they never get over it or they get over it, but it comes back every month. No matter what they do, it keeps coming back. And what's going on is their immune system is finding it, killing it, it shifts, goes to something else, and then the immune system has to learn all over again, which is exhausting. So the point is that parasites don't just attack our immune system, they manipulate the immune system. So the immune system has this very difficult task of trying to figure out what's a parasite and what's not. And some parasites create lipopolysaccharides that on the outside of the cells that's almost identical to human tissue, right? So it takes a very finely tuned immune system to be able to say, that's a parasite, I'm going to kill that. That's normal tissue, I'm leaving it alone. And if it's not really fine tuned, then either it ignores the parasite because it undershoots the mark, or it kills the parasite and causes autoimmune, which is overshooting the mark. Right? There's this very narrow window that the immune system has to be able to maintain to go after parasites. And cancer is actually very similar. Cancer cells don't just look like human tissue, they are human tissue. So, and here's an example. Tumors create a cytokine called tumor growth factor beta that converts T regulatory cells into a form that ignores cancer, right? So tumors teach the immune system to ignore it. They also downregulate something called MHC1, major histocompatibility complex 1, just enough. If the cancer cells lowered MHC too much, the T cells of the immune system would kill the cancer. And if they didn't lower it enough, then the natural killer cells kill them. I might have got that backwards. If you have too little, if the MHC goes down too low, then the T cells kill the cancer. And if the MHC goes too high, the natural killer cells kills the cancer. So the cancer is threading the needle. It's keeping the immune system in this very finely balanced point where it can't fight the cancer, right? It's making it so that the it's balancing. Cancer is balancing the immune system on the head of a needle so we can't see it, right? So what we really want is an immune system that's up to the task. Now, cancer behaves so much like a parasite that I'm convinced it's actually caused by one or viruses, which are parasites. It had to evolve over millions of years to get this sophisticated. There's no way cancer cells could figure out all these tricks in a single lifetime. So we're dealing with a very old adversary. I think these are parasites and they're manifesting as cancer. Now, the question is, are parasites and cancer unstoppable? Are they inevitable? No, it's not the case. Parasites might be 500 million years old with a lot of tricks up their sleeve, but the bacteria and the microbiome are 3.5 billion years old. And they've seen every trick in the book, right? Nothing new under the sun for the bacteria. Our microbiome is definitely up to the challenge of unmasking parasites rapidly so that as soon as it changes to a new form, the immune system is on it like a guard dog, just knocking it out, or the same with cancer. But we have to feed it properly. Now, the microbiome has 1,000 times more genetic material than we do. So it's got billions of years of learning how to deal with parasites tucked away in its collected genome. This is one of the reasons why we want a very genetically diverse microbiome, because we want to have as many different skill sets We want our microbiome to have as much data as possible for dealing with as many different types of parasites and things as possible. So let me see. A healthy microbiome, it can kill or inhibit parasites, including Toxoplasma gondii, Giardia, Cryptosporidium, Trichinella, Babesia, Lyme. And it does it not only directly by killing it in the gut, but indirectly by teaching the immune system, this is not the self, go get it. So we're taught that we have two different forms of the immune system, two branches, right? We're taught that we have the innate and the acquired. And there's actually a third. The third is actually the microbiome itself. And it's arguably, without the microbiome, functionally, we really just don't have we don't have an immune system. We have a car without a driver. We have the ability to do something, but no knowledge of what to do with it. It's the advisor we need running behind the scenes. So, any questions on those things?
I think there was one question that popped up,
Sure.
relationship with lymphatics. And I think that refer back to the original biome and what is the relationship it has with the lymphatic system.
Well, one of the things is the lymphatics are carrying the microbiome of the mother to the mother's from her gut to her breast to give to the baby, right? But 75% of your immune system is in the gut-associated lymphatic tissue. So there it is. If you were to take all of your immune cells in your bone marrow and your blood, it wouldn't equal the amount of immune tissue in your gut. Your gut is your immune system, functionally. And your lymphatics is that the Paris patches are that.
I think the question was a little bit more related on if you have a bad biome, how do what kind of effect is it going to have on the lymphatic system?
Well, so your lymphatic system is detoxification and immune function, right?
Correct.
Your microbiome does most of your detoxing for you. And we always think the liver is detoxifying. Yes, and the microbiome does detoxifying, a huge amount of detoxification. And the microbiome is also the major part of your immune system. So if the microbiome isn't functioning properly, you have less ability to deal with toxins, and you have less ability to deal with infections, both of which are the job that are what is tasked to the lymphatic system. So they work hand in hand.
Okay. So no other questions for now. So if anybody has any questions, they can, I don't know, raise your hand, or there's a couple different options in there.
All right, we could go on for the microbiome for another hour. We could talk about, it goes on so deep, but the complexity of the microbiome is only matched by the simplicity of the solution. Every time you find one more thing the microbiome does, for all its complexity, you keep coming back to the same thing. Just feed it. Just give it some food.
No, exactly.
It's not probiotics. You can't buy the probiotics you need. And even if you could, what would it matter if you don't feed them anyway? You've probably already got every probiotic you need in your gut, and it's just sleeping. All you really need to do is to feed it. And unless you feel like going out into the bush of Africa and digging up roots 3 hours a day and eating tubers and insects and hunting wild game, if you want oligosaccharides, you're going to have to take it as a supplement. At least it tastes good.
Well, yeah, that's a plus.
Yeah.
I did want to mention really quick while everybody's on here. So the pancreas product is in our store. I think it should be live by the time this call is over. It should be live, and I actually did a 20% discount just off of this webinar. So whoever's listening can get 20%. And if you guys want to use webinar 22, as in the year 2022, all one word or lowercase. So you guys can jump in and take advantage of it since you guys joined in on the call. So.
Yes, Gasper's got a question, or Miss Gasper. Can you get her volume up?
Let's see. You looks like you're muted. So just, there you go.
Good. So it's so nice to see you guys face to face. I am using most of your products already, and I was just, I'm maybe a little bit too paranoid or too old, either or. This for the parasite and the biofilm, this Zobian, right?
Mhm.
Yeah.
Will it kill effectively if anything bad is going on? And how long I have to take it? Maybe 3 months or more?
So Zoibin is sort of like phase 1, right? We're trying to knock down things that don't belong in there. But at some point in time, you need to have your microbiome do that for you. Now, granted, the way the body is designed, it is expected that we're going to be eating essential oils and bitters in our diet, and we don't. So a little bit of Zoibin, thank you for the reminder, a little bit of Zoibin now and again.
Actually, I love it, yes.
Oh, God, that tastes so bad.
It tastes so bad, but I like it, yes.
A little bit of the Zoibin now again, I think, is an important stimulus to the body, but not necessarily something I would do every day. So, you know, I might do Zoibin like every 3 days. I take a little bit, right, every 4 days. But the Panaceum, the food, the oligosaccharides, that's something I would do 3 times a day, because that is something
That's the only one I don't have yet. I mean, almost the only one. So I'm definitely taking advantage on.
And that should be, and that is what is your day-to-day defense against all these bacteria. You know, if your microbiome is good, then the digestion improves, and then you can digest fat. And if you digest fat, your body makes caprylic acid. And if you make caprylic acid, that's the natural way that candida is removed. I mean, it's the microbiome is in charge of so many things. It's mind-boggling.
Yeah, maybe that's the missing link, because I know I do have autoimmune something going on, and I go to a naturopath doctor and we try to figure out, and he keeps saying fiber, fiber, fiber.
No.
And like, okay, so no.
No, autoimmune is a failure of the immune system to recognize self. And the immune system can't recognize self. It's not its job to recognize self. That's the job of the microbiome to teach it. The microbiome is required for the immune system to know what is self and what is not, right? So you've got a fine army. They don't have the right marching orders. Somehow your army got turned around and is now going back against its own, you know, it's coming and going after itself. So, you know, the army has to have a general. You've got the army, but the instructions on what to do are the microbiome. And, you know, your practitioner is kind of on the right path. He's like fiber, or she's fiber, fiber. That your practitioner is recognizing that it has something to do with the gut. What they haven't recognized is that what does it have to do with the gut, and how do you do it properly? And fiber will slow down transit time and irritate the gut. And so what I would say is it's much better to get your fiber as food than as a supplement, which can cause all sorts of issues.
Yeah. All right. Well, thank you.
Yep. Okay, I see something with no matter how little food I may eat, I must sleep afterwards. Something wrong with my gut. Okay, so what you could be getting is postprandial fatigue, which is when you get tired after you eat. So that could be your blood sugar, right? Is one issue. So the first thing I'd want to do is I would say, go get yourself an inexpensive blood sugar. Go get yourself an inexpensive blood sugar meter and check your blood sugar before you eat. And then like, as you eat, you know, and then just check it like every 10, 15 minutes after you eat and see if you get a crash. And if that's going on, then what's happening is you're not regulating your blood sugar, right? Okay,
Wow.
whose job is it to regulate things? You think it's your brain.
Right.
It's not your brain's job to regulate things. Your brain's job is to organize data coming in from the nervous system, and you know, and process thoughts and sensory information and motor information. The job of regulation is your microbiome. its job is to manage things like this. So when you see yourself going off to extremes, right? If someone who sleeps all the time or can never get to sleep, that's a problem with homeostasis. Any of these homeostatic issues are microbiome oriented. So yes, it's probably your blood sugar. And why is the blood sugar out of whack? It's not being regulated. Why is it not being regulated? Okay, probably your gut. I mean, you should be getting some degree of rest and digest stimulation when you eat food. It should calm you down, right? You shouldn't be getting the signal to go out and run a marathon because you're now moving towards a different process, right? You need to calm down and relax to digest well. But if you rest too much, then you're passing out, right? So you've got the right process, but it's off on the extremes. That's a microbiome issue.
Okay. Thank you.
You're welcome, Eileen.
You can hear that?
I can hear
Yep.
you now.
Yep.
Oh,
Looks like you're unmuted.
well, how do I get my picture up there?
Yes, I want to see you, Eileen.
I don't know how to do that.
There
There's
should be a little
button.
camera button.
Yeah.
Camera.
Bottom left-hand corner, I think. It says
Bottom left.
Start video.
Yes. I'm clicking it.
Well,
Select
computers.
the camera.
Let's see.
Video. I'm working on it.
Well, if there aren't
There
any
you
more
go.
questions.
I'm gonna ask you to start video, so it should.
My video. Touch up my appearance. Video. Okay. Not share screen.
No.
Not your screen. Yeah, it should just say start video. It'll be like a little.
Yeah, it says start video, but
Yeah, sometimes computers do funny things, Eileen. But it was nice
oh,
meeting
here
you.
I see start. I hit it there. Still not working.
I did post in the chat. I did post the code.
Mhm.
So, and it's going to be webinar as WEBINAR, and then the number 22. So webinar 22. So that's going to get you 20% off until I think tomorrow.
Okay.
Well, I see our hour is up. I hope you guys found this useful.
Yeah, super informative.
I can tell you real quick a personal experience that happened for me. So one of the first things that happened is I noticed my eyesight was getting better, and eyesight has to do with microcirculation. The eyes have very fine nerves and blood vessels and muscles. It's not like the thigh muscle with a giant big femoral artery. So one of the things that happens as you get older is the microcirculation goes, and then the eyesight's one of the first things that goes with it. So my eyesight started getting better. I didn't need glasses to read as much. The next thing that happened is I'm in the gym, and my physical strength and endurance got much better very quickly, which was not expected. Another thing that happened is my sense of balance. For the first time in my life, I have a sense of balance. I can stand on one foot and take off my shoe and not fall over. I think I lost that when I was an infant with a head injury during childbirth. So even if you have a head injury that's 53 years old, you can still be recovered. And I got to tell you, I can finally dance now, which I could never do before. And boy, it's a lot of fun. I've got 53 years of dancing to catch up on, because anytime I tried to dance, I'd always fall over on myself. And now I'm just dancing all along, I put on music and I dance around the house. And then the last thing that happened was my skin got a lot stronger. So I live on a farm, I live off grid. And one of the things I noticed is if I'd handle barbed wire or, sharp, wood with splinters, my skin would rip really easily. And I kept thinking, gosh, it seems a lot more fragile than when I was younger. And I caught my foot in a door the other day when I was barefoot, and I could have sworn I just gashed my top and the back of my foot. And I get back home and I'm going to look at it to see how badly I'm bleeding. And if I need stitches, no blood. It didn't even cut the skin. It only turned it red, which it would have shredded me a couple of, before 2 months ago, I would have, probably need a little bit of crazy glue or some stitches from that. And so I'm thinking, gosh, that's interesting. My eyesight's improving, getting stronger, more endurance, better balance, stronger skin. Oh, I know what all these have in common. These are all things that get worse with age. I'm getting
Yep.
younger. So yeah, gets you younger.
Yeah, and I think we all talk, even, in every webinar, I think we speak of diet. So, and, diet is probably the number one most important thing versus supplementation. So diet, mental health, and then supplementation probably is, in the order of ranking. And
Yeah.
you eat, and, a lot of traditional medicine, they really avoid talking about about diet, or mental health, or supplementation. So
I wish
it's,
there was a way to do this with diet. I wish there was.
yeah. Well, but this is, I think, this is diet.
It is.
And I think that,
Yeah.
this, I think that's why, I think this is the number one thing, right? And, everything I always say when, we do, one-on-one calls with people who take peptides and such, I always tell them, hey, you got to make sure you're eating right. So, and being able to eat right can help fix a lot of things, or can help your body fix a lot of things. And I think this is, on a priority level, this is back to that eating right. So I'm making sure we have all of it. So, yeah, well, I appreciate the information. I'm gonna go order some for myself. So, but yeah, and well, we'll post the video in a couple months, and with my
the
story.
animals, when they recover an animal's microbiome, when they've transplanted the microbiome of a young rat into an old rat, the old rat starts looking and behaving younger. The hair gets thicker and shinier and darker. The skin gets stronger. It puts on muscle. It starts doing mounting behavior. It becomes sexual when it's when the old mouse stops being sexual. It becomes more intelligent. So you can rejuvenate an old mouse by giving it the microbiome of a young mouse. Well, I'm here to tell you, you can rejuvenate a middle-aged man by eating oligosaccharides.
Yeah, maybe I'll grow my hair back again.
I wouldn't be surprised. That's what I'm trying to wonder, because it's happening with the mice. So I'm looking to see if in like 4 months this turns black again, and I would not be surprised if it does.
Awesome. And there was one last question, I think from Aline. She said loves the products and the presentation. She's using Metacardium, Glytamins, and Zenaplex right now. Is it okay to do them in the morning and Rejuvenate at night?
Yeah, sure. Great way to do it. I like Rejuvenate at night because that's the time when you're ordinarily and naturally going in your repair cycle. So that's a good way to time that.
Awesome. Well, I appreciate everybody's comments, and Spencer, for your time and your creativity on coming up with these products. So they've been life-changing. So for me, and I'm guessing for a lot of people. So.
Wow, that's awesome. All right. Well, it was nice meeting you all digitally, and have a great weekend.